We've come a long way. Part 1 gave us single agent foundations. Part 2 introduced multi-agent collaboration. Part 3 added structure with workflow-based architectures. But there's a missing ingredient. Everything we've built so far produces output on the first try and calls it done. What if the agent could look at its own work, recognize mistakes, and fix them? What if it could ask a human for help at exactly the right moment? What if your retrieval pipeline could reason about what it needs instead of blindly searching? This episode is about making agents genuinely intelligent. The reflection loop is deceptively simple but dramatically effective. The agent attempts a task, it evaluates the result, it reflects on what went wrong, and it retries with the reflection injected as additional context. Each iteration gets better because the agent carries forward lessons learned from previous attempts. The evaluation step is where you have design choices. The same model can self-evaluate. Does my SQL query handle null values correctly? A different model can serve as an external critic, or you can use deterministic checks. Run the generated code against unit tests, validate SQL syntax, compare row counts against the source data. The key insight is what happens with the reflection. It's not just try again. The agent produces a natural language analysis. My first attempt failed because I didn't handle the edge case where the join key contains nulls. I need to add a coalesce wrapper. This reflection is injected into the next attempt's context, making the retry meaningfully different from the first try. Reflection dramatically improves code generation, SQL writing, migration accuracy, and document quality. In benchmarks, it can take a 70% accurate first attempt to over 90% in just 2 to 3 iterations. The generator critic pattern inspired by constitutional AI takes reflection and makes the roles explicit. Instead of one model doing everything, you separate 3 distinct functions: the generator, the critic, and the reviser. The generator focuses purely on producing the best initial output it can. The critic evaluates against specific, predefined criteria. Is the output accurate? Is it complete? Does it follow the required format? Are there security concerns? The reviser takes both the original output and the critique and produces an improved version. Here's a concrete enterprise example. You're migrating Hive queries to PySpark. The generator produces the PySpark code. The critic checks, does this produce the same results as the Hive original? Are there performance anti-patterns like unnecessary shuffles? Does it handle the edge case where partition columns are null? The reviser fixes every issue the critic flagged. These can be the same model with different system prompts, which is simple and cheap, or different models use a fast model for generation, a powerful model for critique. The key is that separating the roles prevents the generator from being blind to its own mistakes. Self-ask is elegantly simple. When faced with a complex question, the agent asks itself, what sub-questions do I need to answer first? It decomposes the problem, answers each sub-question independently, potentially using different tools for each, and then synthesizes everything into a comprehensive final answer. This pattern is particularly powerful for complex analytical questions where a single search or tool call can't provide the full picture. Instead of hoping the agent stumbles onto the right approach, it systematically identifies what information it needs and goes after each piece deliberately. Self-ask composes beautifully with other patterns. Each sub-question can trigger its own tool use, RAG retrieval, or even a mini agent loop. It's a meta pattern that makes other patterns more effective. Every architecture we've discussed in this series can be augmented with human checkpoints. This is where the agent pauses for human approval, feedback, or course correction before continuing. In production enterprise systems, this isn't a nice to have, it's essential. Full autonomy is simply too risky for most business-critical workflows. The critical design question is, where do you place the checkpoints? There are 3 rules of thumb. Rule 1. Checkpoint before irreversible actions. If the agent is about to send an email, execute a database migration, deploy code to production, or make an API call that changes state, pause and get human approval first. You can undo analysis. You can't undo a production deployment. Rule 2. Checkpoint after high-stakes decisions. If the agent has just made a financial recommendation, generated legal document changes, or produced a medical assessment, have a human verify before acting on it. Rule 3. Always include an escalation path. Set a confidence threshold. If the agent's certainty drops below, say 80%, it should automatically escalate to a human rather than guessing. For novel situations the agent hasn't encountered, edge cases with ambiguous requirements, and any scenario where the agent detects conflicting information, route to a human. The implementation pattern matters too. Synchronous checkpoints, where the agent waits for human response, work for interactive applications. Asynchronous checkpoints, where the agent saves state and resumes when the human responds, work for batch processing and background workflows. Most enterprise systems need both. You've probably heard of RAG, Retrieval Augmented Generation. In its basic form, it's a simple 3-step pipeline. Take the user's query, retrieve relevant documents from a vector store, and generate a response using the retrieved context. Simple, effective, and limited. Agentic RAG wraps retrieval inside an agent loop, transforming it from a pipeline into an intelligent process. The agent doesn't just retrieve, it reasons about retrieval. It decides when to retrieve, what queries to construct, evaluates whether the results are sufficient, reformulates queries when they're not, searches across multiple data sources, cross-references results for consistency, and determines when it has enough information to give a confident answer. Here's why this matters. Imagine a user asks, what's the performance impact of migrating our Delta Lake tables to Apache Iceberg? Basic RAG searches once, grabs whatever the vector store returns, maybe a blog post from 2 years ago, and generates a response. Agentic RAG reasons, I need benchmark data, compatibility notes, and migration gotchas. It searches 3 different sources, evaluates that the benchmark data is outdated, searches for newer benchmarks, cross-references the compatibility notes, and only then generates a comprehensive answer. The trade-off is latency and cost. Multiple retrieval rounds take more time and tokens than a single pass. But for knowledge-intensive enterprise use cases where answer quality matters, technical documentation, compliance questions, migration planning, Agentic RAG is worth the investment. Here's the powerful insight. Every pattern in this episode is a modifier that you layer onto the architectures from parts 1 through 3. You don't choose reflection or multi-agent, you combine them. An orchestrator worker system where the coding worker uses reflection to iteratively improve its migrations. The report writer uses generator critic to polish the final document. The research worker uses agentic RAG to gather comprehensive context, and a human checkpoint gates the final deliverable before it reaches the client. That's a real production architecture. That's what enterprise grade looks like. That's part 4. You now have the intelligence layer, reflection for iterative improvement, generator critic for quality assurance, self-ask for systematic decomposition, human in the loop for production safety, and agentic RAG for intelligent retrieval. We have 1 episode left, and it's the most practical one. In part 5, we compare every major framework, LangGraph, CrewAI, Bedrock agents, and more. We cover the 5 production concerns that make or break your deployment. And we give you a decision guide to pick the right architecture for any use case. Don't miss it.